Now, in the previous video we covered looking at logarithmic axes and plotting graphs on these to make sure that they fit. And we covered one form of the equation where it could be something along the lines of y equals ab to the power of x. So our variable x was the power within the equation. We can also do that for other forms of the equation where x is not the power. The dependent variable is not the power. So we've got something of this form here. Y equals ax to the power of n. Now something like this almost looks like our exponential equation that we know and we love. And it certainly is. When we take the log of both sides, we get a slightly different form for our equation of a straight line though, and that's what we're going to look at today. So here we go. Imagine we do take the log and we want to plot it as a straight line. So we want it to look something along the lines of this. Now we know y equals ax to the power of n is the form that we want. To do this and to turn it into a straight line on a set of logarithmic axes, again we take the log of both sides. So this time I'm going to do log to the base e of y equals log to the base e of ax to the n. One key thing actually I should point out is the base here doesn't matter as long as it's the same on both sides. I'll show that to you with a later example. Split up the one on the right hand side using our rules of logarithms. Log to the base e of a plus log to the base e of x to the n, and then bring the power down using our other rule. What we get then is log to the base e of y equals n times log to the base e of x plus log to the base e of a. Now again, this is in a similar sort of form to a straight line equation, y equals mx plus c. However, it's different from the previous type of logarithmic axis plotting. In the previous one, the x in the straight line marred up to just an x on its own. There was no logarithmic dependence or effect. However, in this one, it mars up to the log to the base e of x. So in the previous one, we wrote log to the base e of y equals a capital Y. In this case, we have to take that into account with both variables, and we have to write capital X equals log to the base e of x. And what that then allows me to do is write it in the form big Y equals n big X plus log to the base e of a. Now I can just leave the log to the base e of a because this is just a constant again. And that allows me to mar it up. So in this case, the n is my gradient and the log to the base e is my y-intercept. So in this case I know that m equals the gradient n, which is the power, and our log to the base e of a comes from the y-intercept. So this part here, the y-intercept, that's going to give me my log to the base e of a, if we imagine this is the plot. But I know that my y-axis, again, that's a log axis, so log to the base e of y. But my x-axis this time is also a logarithmic axis for this sort of equation. That's the big difference between the two of them. Now, in terms of general way that we do it, it doesn't really change too much. It's just a little bit more algebra skills have to come into play because we're working and manipulating logs. So why don't we have a look at a couple of examples for this and let's see how we get on. So imagine I do an experiment and here are the results from the experiment shown in this table below. So log to the base 10 of x and log to the base 10 of y are related to each other by these results. My relationship connecting the data, what I'm going to tell you is it's of the form y equals ax to the power of b. So it's the form that we want. I want to find a and b and state y as an equation in terms of x. Well, in order to do this, start with your y equals ax to the power of b and take the logs of both sides. Now in this case it's log to the base 10 here, so it's log to the base 10 of both sides I take. So I get log to the base 10 of y equals log to the base 10 of ax to the power of b. Manipulate it using the rules of logs and you get log to the base 10 of y equals log to the base 10 of x times b plus log to the base 10 of a. And again, we know that this is related to the y equals mx plus c form, and I can read off what my gradient is and what my y-intercept is. I know my gradient is equal to the b, and c, my y-intercept, is equal to the log 10 of a. Now, I can take any data I want and get either of these two. If I can read off the c, great, but I can't in this case. So I have to start with the gradient. Now in this case, I know the gradient, which is equal to my b, is y2 minus y1 over x2 minus x1. Now, they're both in the logarithmic form here, which is great. They have to be at this point to be able to work straight away. If it's not in this case, I've got to take the logs first before I then put them into my gradient formula. They are here, so it's great. So let's pick any 2 points. I'll pick the first and last to show it doesn't matter which ones we pick. y2 minus y1, so 2.10 take away 1.33 over x2 minus x1 divided by 2.85 take away 1.70. Stick these together in a calculator, work them through, and I get my gradient is 0.59 to 2 decimal places. So I've got my gradient in my line. What I'm able to write now is that big Y equals 0.59 times x plus log to the base 10 of a. Now remember, big Y, big X, we're thinking of them as being log to the base 10 of y, and big X we're thinking of being log to the base 10 of x. What we can now do is pick a point, pick a bit of data, substitute it in, and then calculate it through. So what I'm going to do is I'm going to substitute in the first point here, and I'm going to say that 1.33 equals 0.59 times 1.70 plus log to the base 10 of a. Now a key thing to note here, remember that the y represents log to the base 10, which is why I've substituted in the whole value here. If my table was relating x and y to each other, I would have to take the logs of the value in the table before substituting them in. I'll show you that in the next example. Bear that in mind though, please don't make that mistake. Once we've got all this here, we manipulate it round and solve it for log to the base 10 of a, and in this case I find that it equals 0.33. Then I need to find a, so I know a is going to be 10 to the power of 0.33, reverse the logarithm, stick that in a calculator, and you get 2.14 to 2 decimal places again. Now, I can then go back to my original equation and plug in. So I know y equals ax plus b, sorry, ax to the power of b, is going to become y equals 2.14 my a, x to the power of b, which I know is 0.59. So that's me solved it and put it back into that form. Using the same sort of steps, the only difference is, with a gradient, remember we're using the logarithms of the powers, same with calculating these bits here. A little extra complexity, but it's actually not too bad. Even when the table's not given to you in terms of logarithms, it's actually not too bad. There's really just one major extra step. So let's look at this. I've got results from another experiment in this table as follows. Relationship connecting the data of this form. Find a and b and state y as an equation in terms of x. Again, start out with your equation. Y equals ax plus b, and take the logs of both sides. Now I'm going to stick to taking log to the base 10 of both sides, just because that's what we had in the previous example. So I get that, and then I can manipulate it using my rules of logarithms, and I get log to the base 10 of y equals b times log to the base 10 of x plus log to the base 10 of a. And again, from this and relating it to my y equals mx plus c form of the straight line, I can get that my gradient is equal to b and my c is equal to log to the base 10 of a. Now I'm going to get the gradient first again, but what I've got to do is I've got to remember this is relating x and y. My straight line equation relates log to the base 10 of x and log to the base 10 of y. So if I pick these 2 points here, I have to take log to the base 10 of both bits of data in there. So I have to take log to the base 10 of 10.3 and 2 for my first point, and I have to take log to the base 10 of this and this for my second point. So when I do y2 minus y1 over x2 minus x1, it's not these ones that I plug in, it's those answers. So what I end up plugging in is 2.036 take away 1.013 over 0.903 take away 0.301. That's the logarithms of both sets of points. Once I've done that, calculate my gradient, and I get 1.699 as my gradient. I can then plug it back into my straight line equation here and calculate from there the rest of the bits of data that I'm after. So I know log to the base 10 of y equals 1.699 times log to the base 10 of x plus my log to the base 10 of a, where my c is. What I can then do is put in a log to the base 10 of x and a log to the base 10 of y, use one of the 2 points I've already got, and shift it round and manipulate it and find a solution for log to the base 10 of x. So what I can then do, imagine I take my first point, which is the one here, so it's this bit of data here from this one, and plug it in. I get 1.013 equals 1.699 times 0.301 plus log to the base 10 of a. Manipulate it and solve it again for log to the base 10 of a, And what I end up getting is log to the base 10 of a equals 0.501. Reverse the log and I get a equals 10 to the power of 0.501, which in this case ends up giving me 3.17 to 2 decimal places. And again, now that I've got a and b, I can write my equation. So now y equals ax plus b is going to give me y equals 3.17 times x to the power of b, and I know that b is equal to 1.699. So I've done the exact same thing. Again, the key thing and the difference with this one is look at the table. They're not in terms of logarithms for this. I have to take the logarithms as I work it through. Right, here's one for you to have a crack at. So here's a plot of results of an experiment, plotted on a logarithmic axis here. Big Y, I'm going to tell you is log to the base e of y. Big X is log to the base e of x. Here's 2 points on the line, and I'm going to tell you that my data forms a line which takes the form y equals ax plus b. What I want you to do is find a and b from the equation, and I want you to write out y in terms of x. So I want to know what the equation is in terms of x back in this original form, y equals ax plus b. Good luck.